Today we'll be talking about lasers, sniffers, drones, and methane. And you may wonder, why did we choose this topic? And the reason is pretty simple. A lot of new regulations regarding methane and all these greenhouse effect gases during the last year and this year, and plenty of news about huge fines for oil and gas companies and for landfill companies. And that's why we decided to discuss today how drones can help in tackling these issues, for monitoring methane, for quantifying methane, and just to make our lives simpler. And today, to support me in this conversation, we have two great guests, two wonderful guests, I would say. First guest I want to like to introduce is Ben Lunenwood from Big Sky Theory from the United Kingdom. Ben, we want to see you here with us. Please switch on your camera. Hi, Ben. Ben knows about aviation, Air Force, and everything like a pro, because he has been working in the United Kingdom Air Forces for 18 years, I believe. And he's a founder of Big Sky Theory, and they do a lot of research and a lot of projects in drones and specifically in methane reconnaissance and detection. And Big Sky Theory launched a huge project called Launch for and Locate. That's a initiative to innovate airborne methane reconnaissance. And today, Ben will be speaking a lot about this project and about this initiative. Ben, that's a great pleasure to have you here.
Thank you very much.
And the second guest today, it's Guillaume. Guillaume Blackburn Lewis from Canada, and namely from Quebec. You can guess it from his name. Hi, Guillaume. Guillaume works for DroneXperts, and he's also expert in air quality payloads and also experts in landfills in Canada. And he'll share today their experience in making landfill lives easier with drones and sniffers and air quality sensors. So I believe we will discuss today oil and gas industry, landfill industry, laser sensor, sniffer sensor, we'll cover the whole area of drones and sensors. A bit about housekeeping today. We have this stream, this webinar also translated on LinkedIn, and my colleague Justina will be helping me with all the comments and questions we've got there. And if you have questions, please use this nice Q&A feature in Zoom. Or if you are watching us on LinkedIn, use comment section and we'll try to answer the majority of questions as much as we can, as many as we can. What else? We are going to spend here 60 minutes, but we can be a bit late, but we'll see. Okay, it's time to start. Enough talking. Let's go to our nice speakers. Ben, you'll be the first today. Please share your presentation and let's go.
Thanks very much, Alexey. You can just give me a thumbs up that we're good to go. Good morning, good afternoon, good evening, everyone. A pleasure to be here. As introduced, my name is Ben Lunenwood. I'm the founder of Big Sky Theory. And yeah, we've started a journey called Launch and Locate, looking at airborne methane reconnaissance. And the word reconnaissance is not by chance. As Alexey has mentioned, I come from a military pedigree, so I had 18 years in the Royal Air Force, the last 8 of which were flying medium altitude, long endurance, remotely piloted air systems, Reaper, and a lot of lessons that I took from there in the intelligence, surveillance, reconnaissance role I brought into Big Sky Theory. And this will become a bit of a thread going through the presentation and the capability, the concept of what it is that we're trying to achieve with this particular sensor. Okay, tunable diode laser absorption spectroscopy, TDLAS. It's often said if you understand the why, the how is easy. So why did we end up going down this particular route? To be honest, it's from hitting hurdles, from clipping and stubbing toes along the way through test and evaluation. I've flown a lot of sensors and underslung loads, and I can honestly say that the biggest failing throughout my career has been attempting to use a piece of equipment that was not designed for that particular purpose. So, moving forward, I would employ upon all of you, if you're working with drones, put drone at the top of your whiteboard before you start your design brainstorming, because there's nothing worse than trying to reverse engineer something into a drone that isn't designed to be there. So from inception to deployment, I started reading up with Future Energy Partners, who have been a real guiding force for the company moving into this particular sphere. How do we use a remotely piloted air system capability within the methane sphere? We then looked at where we were going to be operating. This is not an office-based capability. We're going to be going out to remote or steer locations. And what we needed to be able to do was be reactive, going back to my time in the military, being able to be on target as soon as possible. So through research, literature reviews, etc., we came across tunable diode LiDAR absorption. And my relationship with SPH Engineering began with Alexey plural and the rest of the team in Riga. I started to engage with them about what it is that we could achieve. And for me, height, speed, and reach were everything. I wanted to negate the need for people to go out into hazardous areas, and I wanted to provide timely intelligence to the user. We also mandated that we had to be able to complete a processing, exploitation, and dissemination cycle, a PED cycle, quickly, effectively, and efficiently, both in the field and back in headquarters using a plethora of GIS modeling systems. There are other capabilities out there. You're about to have another brief to look at the alternatives. But for me, with this particular reconnaissance role, we went down the laser route. That isn't to belittle or try and downplay what other sensors can do, but for me personally, with the geolocation of high pressure methane releases in the oil and gas industry, the spectroscopic route was a natural avenue for us to take. So the journey for the company so far. Emissions reconnaissance, as we mentioned, was the concept. It was the preliminary survey of a particular site in order to be able to revisit that site in more detail with other sensors that could look at perhaps different gases or in more detail at methane. So with Future Energy Partners, I started to look at the demand within oil and gas. I started to think about the notion of designing our own system, but very quickly saw that there were commercial off-the-shelf COTS systems that are readily available that were doing a good job. And from an operational background, I then started to look at the demand, look at those systems that were available, look at the operating environment, and come up with a plan as to how we were going to move into a space of, as the slide title gives, is innovation through validation. It's being able to provide in-depth analysis of a particular sensor, in this case, the Falcon, in order to provide assurance that the data set that you're getting is accurate. So as I've said, lessons identified. I haven't always got it right. From a lot of previous experience, it's what not to do rather than what to do has shaped the launch and locate operating model. And none of this could have been possible without the National Physical Laboratory. So I've been very, very lucky to have been accepted through the Measurement for Business program, which is time with the scientists at Teddington in the UK to get into the weeds of a Falcon, pretty much popping the chassis off the back to have a look at the sensor construct and the technical capabilities of what it could do. And alongside MPL, I was then lucky enough to be accepted by Innovate UK to go and complete operational test and evaluation. Again, them coming in on the journey of innovation through validation. And that ability for the company to operationally test and evaluate and provide a justified position of just how good this piece of equipment and operating model are. But don't be afraid to get it wrong. That's all part of the journey. So barriers to entry with drones, risk. Risk is everything. We all know that, and I think I'm speaking to a friendly audience here, drones are going to be part of our future across a broad range of execution models and capabilities. But there are still a lot of skeptics out there and a generational divide of this is the way we've always done it versus embracing innovation and technology. When it comes to oil and gas, especially upstream oil and gas, one of the major challenges is, and the image is down in the bottom right-hand corner, the consequence of something going wrong is usually catastrophic. You don't tend to have small accidents at these installations. So working with SPH, working through the UgCS operating model, what I was trying to do was design a concept of employment that reduced the likelihood of things going wrong, because there was very little I could do about the consequence of something going wrong. So technologically, and I'll introduce you to the aircraft shortly, we've looked at detection and avoidance systems. We've got the sensor itself, which we've made eye-safe. And then we blended that with procedural safety in order to bring the end user, the customer, oil and gas, into the journey with us, into the dialogue and the conversation with us to allow them to help us shape an operating model that they would support with us moving into an oil and gas environment with a drone, with a sensor. So it's important to note that automation, AI, etc., is developing on a daily, if not minute, hourly basis. But there are still end users out there that would prefer manual flight operation over automation. It might sound quite strange, but it is true. I've gone down the automated flight route wherever possible. As part of the risk assessment, it allows me to be an observer rather than a pilot. I am a pilot, but it means that I can now look after everything else rather than attempting to fly an accurate raster scan. And this is where UgCS as a mission planning and autopilot software system came into the fold. It also allows us real-time situational awareness and audit of the telemetry logs. And I was able to give a tablet to a foreman on site, and they could keep an eye on the aircraft, again, bringing them along on the journey through the lens of risk, which allowed them to start accepting what it is that we were trying to achieve. Operational safety cases in the UK, I'm sure, across countries, across the world, very, very difficult beast to get right first go. The risk assessment and the method statements are critical to this. And of course, the risk assessment within oil and gas runs alongside those within your aviation authority. So this is something that we've had to spend a lot of time on enhancing, amending in order to enable oil and gas operations. And finally, what we weren't trying to do was provide a complete step away from standardized sniffer technologies with walkover surveys. So the BSEN 15446 standardized process of methane detection and measurement is handheld sniffer technology. And what we're trying to do through the reconnaissance role, there's that word reconnaissance again, is not just tell the end user where they need to look, but also allow them to gain an understanding of where not to look. So it makes their inspection model and their strategy that much more efficient and timely. So research and development, where did it all start? So measurement for business. As I've said, this was a huge literature review to make sure really that we had the right piece of equipment in the Falcon. We looked at the original equipment manufacturer capability statements, and then we decided to question them all in the lab. We saw this as an operational test and evaluation prerequisite. We needed to know, does 1 equal 1, as per the manual? Or is there a slight variation there? And we started to begin this understand phase of what the Falcon could bring to an inspection model. Technologically, a piece of equipment can be phenomenal, but unless you have the right operating model, and in this particular example, we're looking at the reflectivity of the ground surface because it is basic IR theory at the end of the day, height, speed, and standoff of the aircraft, And then Mother Nature, she has a big part to play in any fugitive airborne emissions. So this is where the M4B process, the project that ran last summer, really stepped forward, and we were able to do a lot of testing in the laboratory and then a lot of testing outside to look at exactly what the equipment could achieve. This then rolled on to operational test and evaluation, and Innovate UK stepped in. And this was 2 trials, 1 mini trial, and then leading into the main event last late summer, autumn time. So to start with, what we needed to do was make sure that the operating model that our hypothesis had lent itself to could be proven. So we looked at the downwash of the aircraft and the effect it was going to have on the air directly underneath the stack, because this is what the laser is measuring. And we also needed to gain an understanding of signal to noise ratios, because grass will have a different figure to shale, sand, pebbles, etc., etc. It also allowed several days of hours and hours and hours of utilizing UgCS as it's meant to be used out in the field, which was a really useful step forward. We then went back, refined SOPs, TTPs, etc., 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 to come up with the best possible operating model. It also allowed us to do a dry run, if you will, a dress rehearsal ready for the main event, which was the week-long trial. So we looked at flight profile, the design and execution, changing those variables one at a time to see how it affected the data that was coming from the Falcon. The National Physical Laboratory were there providing scientifically controlled releases of methane from 5 liters a minute up to 75 liters a minute, and many steps in between. Again, just to look at the probability of detection and also plume shapes in the ambient air. We then started to look at the meteorological factors, and this is where we didn't really have a say in it. It was whatever Mother Nature was throwing at us on the day. It will come as no surprise that a nice steady wind will give you a lovely plume. But the point of the reconnaissance model is really to pinpoint the source rather than to create images of plumes and clouds. We looked at the Falcon sensitivity, just how low could we go? And then we started looking at the timeline in order of, the magnitude of providing a service where arriving on site to providing some sort of actionable intelligence to those that are around you that work in the industry. And this involved this PED cycle: processing, exploitation, dissemination, which is where the UgCS model and the LMC software that comes with the Falcon can create a report in short order prior to third-party GIS modeling that you can do back in your office. So, very quickly, UgCS is running in the top left-hand corner, which provides an output in the field. You can do this in the field if you want to, into a software package called LMC by Perkins Suisse. Over on the right-hand side, this is where the real-time intelligence is crucial for me as an operator, where we've got the custom payload manager, and this is showing the gas detector. This particular example is taken from a laboratory, actually, with a gas cell, where we were pushing a gas cell in front of the sensor to look at base level readings, if you will, of the sensor with these particular concentrations. Well, what it means is we could set up points of interest whilst airborne using UgCS, so that we could then refine the search and go back to that at a later date. So this is a very quick canter through what the launch and locate model looks like before you get into third-party GIS using whichever platform you wish to use. And what did it all lead to? So 30 hours of simulation in the lab. A room with no windows, but we achieved a lot in those 30 hours. That then fed into 110 sorties over 8 days in the field, roughly about 35 minutes per sortie. And it proved the accurate geolocation and prioritization of fugitive emissions is possible using a laser spectroscopic approach. The UAV concept of employment, we're constantly refining it as we learn more about what the sensor can do. And we in this particular series of trials, we've gone down to 5 liters a minute, and our next phase is to go lower again. The highlight of the trial was basically a game of hide and seek. Well, I had no idea where the leak was in a field roughly 100 meters by 100 meters. And in about an hour, we were able to pinpoint the emission down to a 3 meter by 3 meters square. So an end-to-end test was a nice way to finish this particular evaluation. Where do I see it going within oil and gas? So we'll continue with the airborne reconnaissance, having proven the geolocation and probability of detection. What we're now looking at is the spectroscopic approach as part of a quantification tool, which is within the LMC software. And again, the innovation through validation, we're going to see whether or not the sensor can be used to quantify to provide a flow rate from a point emission. We're currently engaging with industry, and that's going to continue as part of that risk assessment journey in order to continue with operational test and evaluation. We've completed one on site with a gas provider. Again, it went very well, and they were very impressed with the platform, with UgCS, and the safety that comes with using drones as opposed to putting people into harm's way. So MPL are going to join us this year again to compare the launch and locate data against their handheld sniffer, their standardized techniques. And then further on, and this isn't to steal anyone's sandwiches from your next speaker, we're going to start looking at, having looked at oil and gas, the other methane emitters that are currently making headlines in the media, landfill, anaerobic digestion, etc., whether or not there is a space for TD LAS reconnaissance in that particular role. Always, I love the academic side of it, so we're going to continue with this test and evaluation to provide as big a data set as we can to industry to help prove and assure and show that spectroscopic detection, reconnaissance, has a place alongside sniffers, alongside imagers, etc., as part of a wider methane management strategy. So that's been 20 minutes, a quick introduction to launch and locate, and the work that we've completed within oil and gas over the last 12 months. I'm not sure if questions are going to come now or at the end, but thank you very much for your time, and I'll hand it back to Alexey.
Thank you so much, Ben. Yeah, we have a couple of questions already, and I suggest we discuss it now before switching to Guillaume. The question from Ole Bjorn from Norway. Are you using a scanning or static single point TDLS system?
Sorry, just repeat.
Are you using a scanning or static single point TDLS system?
I'm not sure if I quite understand the question.
As far as I understand, it's static single point. I mean laser falcon.
Oh, yes. Sorry, I've got your question now. Yes, absolutely. We haven't tried to alter the initial design of how the Falcon was due to be employed. We haven't played around with the sensor refresh in terms of the hertz rate. We basically looked at the variables, and then we're building up that actionable intelligence from a set of known figures in order to create the GIS modeling. But yeah, you are absolutely right. Single point is our methodology currently. But as we begin to understand the sensor, we might broaden that out.
Okay, guys and girls in the comments in the webinar chat, please use Q&A function of Zoom platform. This will help us not to lose any questions because there are plenty of them now. Okay. The next question from Jocelyn. Do you measure the wind speed and direction? And if yes, how?
Sorry, my link isn't great. Alexey, can you just repeat the question again?
Yeah, sure. Do you measure the wind speed and direction? And if yes, how do you do it?
So at the moment, I have a meteorological lab, if you will, that works via Bluetooth. and I have it set up to about 1.5 meters. So it's a ground-based sensor. And before I fly, I take the ambient wind measurement. Yeah, it's very accurate actually. The meteorological side is part of the inspection model that will continue to evolve, as it's often the space where there is loads and loads of movement at the moment with ultrasonic anemometers, et cetera. I know that SPH are working on one. So yeah, being able to measure the wind in real time is crucial. It's not something that you can take a forecast from a television station in the morning and then go and fly
on. Okay. As the next question from Ken. Ken, come on. How high can you fly? What is the altitude?
So the sensor, I mean, this is open source. The sensor is cleared up to 100 feet, but I haven't flown it that high. At the end of the day, it's an infrared sensor. It's firing a laser to the ground to measure reflectivity. So these are the parameters that you have to look at in order to create the best possible flight profile. Also, the higher that you go in the drone world, you're opening yourself up to airborne risk. So it's finding that sweet spot in the middle.
Okay, thank you. A couple of questions for those who joined us a bit late. What sensor do you use, Ben, for methane detection?
So I do apologize. I use the Falcon, which is a product that I procured through SPH. You can see it on their website. Weighs about 920 grams. Perhaps I should do a screen share again to show it to you.
Yes, please. That would be nice.
Was on one of the slides. Okay, so unfortunately, it's a little bit blocked out by the EOIR camera strapped to the front, but the sensor here has been designed from the ground up for use on a remotely piloted air system on a drone. I, like many, have gone down the DJI route using the Matrice 300, upgrading to the 350. And I can quickly walk you around the drone. So there's the Falcon, which is connected via the SPH SkyHub, which is the brains of the operation. In order to de-risk the operating model, I've invested through SPH into an obstacle avoidance, millimetric wave radar, and a terrain following millimetric wave radar. We've also added an EOIR camera, which is the standard Zemuse XT2, and we've upgraded to the H20T. And then on top, in order to provide the last piece of assurance, we've got a Para-Zero chute reserve flight termination system, which runs completely separately from the DJI command and control system. So it has its own activation device, but can also be activated automatically with the power loss of the drone. So yeah, remiss of me. The Falcon 1.0, the first edition, is the sensor in question.
Yeah, thank you again. We have so many questions. Let me ask you the last one and we switch to Guillaume, and we'll definitely discuss all these questions after we finish with presentations. The question from Luis Enrique Rodriguez. Do you have experience in detecting leaks in gas pipelines or only in a specific area?
So the operational test that I did at a gas site, we were operating in and around pipelines. So yes, but it's not been extensive. This was a demonstration to look at the capability. So my testing to date has been much more of a scientifically based of a more scientifically based nature, looking at controlled releases to identify where the variations are in the sensor. But if there's gas present, whether it's coming out of manufacturing equipment, processing equipment, or a pipeline, the sensor should pick it up.
Good. Okay, and there was the second part about the recommended height. It's also 10 to 15 meters. That's the recommended altitude for all these flights with laser falcon. Okay, thank you for all your questions. You can still add your questions here and we'll certainly discuss them. But now it's time for Guillaume to share their experience with another type of methane detectors, sniffer type and chemical type. Guillaume, the floor is yours. Ben,
right.
Thank you again for this wonderful presentation.
Thank you, Alexey, and thank you to Ben for the presentation. I'm just making sure everything is good here. All right, so today I will showcase you a different kind of technology. Ben went with the laser solution. So we're gonna go on the sniffer side. I'm gonna explain to you the advantage of the sniffer, why we picked the sniffer, what kind of applications we're doing, and how we can save time and save costs on the field. Quick background, Guillaume Blackburn Lewis. I have a bachelor's in geography and a postgrad in GIS. Before working in the drone industry, I was working in the surveying industry. I have now been working at DroneXperts for over 2 years now. DroneXperts is a center of expertise in drone based in Quebec City in Canada. We have been established since 2012 now. At first, we started manufacturing our own drones with our R&D team. But after a while, we decided to just adopt what is on the market. So the big players like DJI, Wingtra, Hotel, Aurelia. So now we've just become a distributor of the major drone brands in the world. But we still have the R&D team, so we're working on different kind of payloads. We integrate solution for different kind of companies. We work with air quality, water sampling, and other needs that can come up with drones. But today we're going to stick to the air quality side. So how did we get into this field? We developed the Enviro DX side of the company because 10 years ago in Quebec, we had a major accident. Train carrying gases derailed and exploded in a small city called Lac Mégantic. So we had this big cloud of gases that was in the air, and now we're like, how could we measure this kind of what's in the air, what kind of concentration do we have, where do we have to evacuate people? So with the technologies at end back in 2012, there was nothing that could be used for this kind of problem. So we've been approached by the Quebec and the Canadian government since we had the drone expertise to develop a system attached to a drone to measure air quality. So here we have the R series SM. So this is a system that will let you monitor air quality in real time. So on top of the drone, we have the BH12 from Iroman, a Finnish company. And also we developed our own system to take samples on 3 different methods. So here we have the probe. Inside the probe, there are 4 other probes, all independent. So depending on the sampling system, or if you're just doing live monitoring, you will be using a different probe. So everything is working independently, depending on what you're trying to measure. So we developed this system with the 3 sampling method. Inside the lung, there is a Tedler bag if you're trying to detect odor issues. We have the 1.4 liter canister, and we're also using the adsorbent tubes. So you can use the 3 methods at the same time, 1 method or 2 methods, depending on what you're trying to detect. On some cases, you will only need the canister sampling or the Tedler sampling, but we like to offer the flexibility. In the drone market, right now, sampling by drone is done only with the Tedler bag, and people are starting to develop the canister solution, but we like to offer the flexibility depending on what we're trying to detect. But for the real-time measuring solution that we're trying to showcase today, I'm going to give you some examples of what we're doing on this side. So right now we are integrating a fixed station from a French company called EcoMesure. So basically fixed stations are used around the world depending on the industry to measure gas concentration. And what we're doing is we are helping them integrate the solution. So basically we have a mobile unit that can measure air quality. On the side here to the right, we have some of the most popular compounds that we can detect and some various ppm range. So for these systems, what do we have is we can measure many gases at the same time. So we can measure, let's say, CH4, CO2, and H2S on the same flight. The gas concentration will be measured in ppm, and every data will be georeferenced and compensated, and everything is displayed in real time. So when we are flying, this is an example, let's say for a landfill. So when we are flying on the landfill and there's no gas being detected, the gas detection line will stay flat. And let's say we are coming up here and we have a hotspot, a red hotspot. So we will have the peak of gas right in real time and display. This map is done in ArcGIS and post-processing, but on the field with the BH12 for my Ramon, you have auto-generated map. And also, so you can intervene quickly. Let's say this is for a landfill. So let's say the gas concentrations were really high. You can go and do a patching job immediately. Or for, let's say, oil and gas industry, a pipeline, you could detect the leak. You intervene, everything is georeferenced. So sometimes there's no need for the mapping, but usually for landfills, we provide mapping. So I'm going to showcase you guys some case studies that we did for landfills back here in Canada. So here we have a picture of the DJI M300 with our 10-meter probe. So I'm going to showcase you an example of CH4 mapping and H2S mapping. This was done using only the measuring system from BH12, from iRoman, the BH12. We didn't do any sampling for this. We only used the real-time measuring system. So this was done in January last year in Quebec City. So this is why there's a little snow cover on this mapping. So what we do is we find the optimal flight path to scan the zone. And what we do is we fly at 10-meter high since the probe is 10 meter. So this way we have no downwash from the propellers like Ben explained earlier in his presentation. So it's the same kind of methodology. If you're using a sniffer or a laser, you don't want any interference from anything that can come up with. So what we do is we're passing on the landfill and we're sniffing up, we're bringing the air from the probe to the system that's attached to the drone. And here we have in the center, we detected a gas leak. We reached up to 100 ppm of CH4. And like I mentioned earlier, while we're scanning one gas, we're scanning another gas. So at the same time, the same exact moment, we flew, we measure CH4, and the H2S sensor will also activate it on the machine, the BH12. So what we have now is two data sets in one flight. So after that, it's really easy to compare where are my leaks, where are my issues. It's easy to monitor infrastructure, where we have issues on the pipeline, the landfills, any chimneys that can come up. Why do I have a leak here? Why do I have a leak there? It's easy to compare. Now these scales for the gases, we did them for the customer, but you could say if the gases reach, let's say 40 ppm of CH4, I want it to show up in red because I want to cap everything. Or if it's under 200, I don't care, I don't want it in red. So this is all done in post-processing depending on the needs of our customer, so we can adapt the data to showcase what we want to see. So what we have, like I mentioned before, we passed at the same time, we measure CH4 and H2S. Usually where there's CH4, there will be H2S. There will be a leak because for the landfills, the capping, when it's done, the gases, they will try to escape at the same places. But what we see on this map is we have a CH4 leak at the northern part, and we have no H2S leak. So when we checked in with the site owner, it made sense to them because they were burying a certain type of waste that it's normal that it was not emitting H2S, but it was very emitting CH4. So I like this example because it shows even though we are flying at the same time, taking the same air and everything through the probe, through the system, it's not because we are reading one gas that we are having false readings for other gases. So it's good to see that everything is working at the same time, but everything is independent. So in this example, we only have H2S and CH4, but when it's CO2 mapping also or NH3 mapping, it's the same kind of a mapping results that are done. So what we have, we're using this measuring system on the M300 from DJI or the 350. Earlier, I showcased you the sampling system and the measuring system on a heavy lifter drone. If you want to do a sampling, you will have to use a bigger drone to do the sampling. But with just the measuring system, we can use it with a small and quick agile drone like the M350 or the 300. It'll be the same system. It'll just be adapted. It just be screwed on a different drone. So it's good for this kind of technologies are good for routine checkups or just emergency situation. We've talked with the Canadian Coast Guard, tried to detect gas concentrations of boats that are coming in from the ports. So there's many different applications that come up. On a legislative perspective, this kind of technology was approved in December 2023 by the US EPA. So we're talking about OTM 51. This was approved with the Sniffer Robotics back in Michigan. So Sniffer is our partner in the United States. So when we didn't work with them at first, but when we saw the US EPA technology and everything, we looked at what they were doing and the methodology we were using, and we used the same kind of methodology. So it's good that the DroneXperts were using the same kind of techniques that were used as now the reference in the USA. So on this side, now Canada is slowly adopting some of these laws. They're looking if they want to go on the sniffer side or the laser side like Ben showcased earlier. So there's no right or wrong way depending on what you're trying to detect. So we will see in the future if the government of Canada will say both methods are good or only one methods are good. This is the things that are being talked about right now. So I cannot really go into details about that. But it's good to see that the landfill industry is adapting to what's being done on the market, to saving time, saving costs and everything, health and safety issues. And it's good to see other industries in the futures like oil and gas and paper mills or any kind of industry will follow up. So the advantage of using these kind of technologies on a drone, well, it's the biggest one will be saving cost and time on the field. When you're using a traditional method, when someone is walking around on a landfill, it can be very dangerous. Some landfill sites are very big, have a lot of activity. So now with the drone, we're simply flying around the site. It's way easier to stop your operation, wait for a truck to pass, or maneuver around a truck than sending someone on the field. And when we talked with other companies that did business with us before, since you're on foot using drones, a sensor in your hand compared to the drone, there's a lot of dangerous areas that you don't want to go. You cannot walk up a pile of waste, let's say, but it's easy to fly over that with a drone. And after that, as people here are aware, once you start integrating one kind of drone service, you kind of want to start to integrate other kinds of drone services. So after that, you can have up-to-date mapping of your site, volumetric surveying. So it lets you unlock new opportunities, new ways to view your site to improve your operations. So, and of course, well, the main goal for most landfills user or operator is to detect the gas leaks. So if you're using this kind of technology, you can detect your gas leak quickly. So you can monitor your infrastructure, detect the gas leak, and do your capping. And it's a big improvement on the kind of technologies that are being used on foot. So it's good to see what's being done on the drone side of things, either on the sniffer side or laser side. For us, we went to the sniffer side because we like the versatility of measuring many gases at the same time. Of course, landfill user CH4 is very big for them since it's a big greenhouse gas. So, but when we can pair it with other sensors like H2S, which comes with a lot of odor complaints, a lot of site owners are very interested in that. So we like the flexibility of the sniffer compared to only measuring one gas at the same time. So for me, on this side, for the sniffer side, this was all of it for me.
Thank you so much, Guillaume. Thank you for this wonderful presentation. You do also have plenty of questions to answer, and let me go one by one. The first one: how much time was spent for the scans of the Quebec scan with the snow? Everyone has liked your snowish photos and screenshots.
Yeah. You want to know the time operation for this kind of mapping?
Yeah.
This was a 50,000 square meter site, and it took us around 4 hours. So it just depends on the speed that you want to fly. We fly around 3 meters a second. So it just depends on how quick you want to be. Like Ben mentioned, if you go too fast, you can have false readings, or you don't want to detect the leak at the wrong spot. We can do surveys during the winter, but as you can see on the picture, there's not much snow anyway, and from a Quebec perspective, there's not much snow. So you can do the kind of mapping, but of course, we do not recommend doing this kind of mapping if there's too big of a snow cover.
And that links us to the next question. What is the impact of snow cover for emissions and also on detection? Is there any impact?
The issue, if there's too much snow, it's possible that the leak, let's say, would be, if there, like on this side, the leak, of course, the CH4 leak is there, but if the whole site was covered in snow, the gas could escape to the place where the snow cover has a leak. So let's say the real physical leak would be there, but the whole site would be covered in snow. Well, the easiest exit for the gas could be over there. So you could detect the leak at the wrong spot, do your capping at the wrong spot. So of course, this is not what the site owner wants. So this is why you need to make sure we make the snow plow before we do a job in the winter for landfills.
Thank you so much. While we are still here on these nice pictures, what was the software to prepare these maps?
So we did this mapping with ArcGIS. So it's simple. When you do the data, you collect the raw data, compensated data, and after that you can use any kind of software. This was done on ArcGIS, but QGIS or any other kind of software could be used to interpret this data.
Here's a question to both of you, because we had the same question for TDLS. What is the best distance between two passes? What is the overlay distance?
So we use 15 meters between the flight paths. This is what best for us because 30 meters starts to being a little too big. And also the US EPA now is also asking for 15 meters between flight paths on landfills anyway. Other industries could be using different distance between flight path, but for us it's being done with 15 meters.
15 meters. Ben, and you, what side distance do you use for laser falcon?
I'm afraid it depends. It's something that we have to revisit on a flight by flight process, given the local environmental conditions. There is no one answer with laser spectroscopy. So yeah, forgive me. I'm not attempting to avoid the question, but it could be a series of numbers. And it also depends on what it is that you're looking to try and achieve with the end product. So yeah, it's been part of the journey. If you go into any inspection model with a preconceived idea that it is one number, you're gonna struggle. So the idea is be open to the data, and the data will start to provide the answers that you're looking for.
Okay. I believe that Guillaume would second you here, because you are right. That's really case by case.
Exactly.
Yeah, there are a lot of questions about what is the duration of each flight. I'll respond to all of them. It really depends on the drone you use, because for instance, for DJI M300 or 350, you can fly up to 35 minutes, I would say. But if you use, for instance, some hybrid drones, gasoline-powered drones, we have recently integrated Laser Falcon and Harris Aerial hybrid drone. It can fly up to 2.5 hours. But so actually, the battery lifetime here is a bottleneck. Okay, tricky but interesting question, deep question from my colleague Alexey. Guillaume, can you compare Sniffer with other methods in terms of cost of ownership and survey performance?
Yeah, well, for the sniffer technologies we're using, it depends if you want to compare to a laser or other sniffer issue. So the price will depend on that. I think one of the advantage of a sniffer, like I mentioned before, is if you can detect many gases, you can detect other problematic gases. From a landfill standpoint, H2S can bring other complaints. We can bring a lot of citizen complaint, which is not good for a site owner. But for the cost, the technology will detect the CH4. If you're using any kind of sniffers, we tested a lot of them. It just depends on the one you're trying to use. At the end of the day, the most important on the saving and cost effectiveness is detecting the gas leak and patching it, so you're losing less money if you're using if you're recycling the gases. In Canada, companies are starting to integrate this kind of services. Also, if you're using these kind of technologies, you will save a lot of operation on time. So I think any kind of sniffer technology that you want to use, just make sure you're having the right methodology, that your sensors are probably rightly calibrated, and on the long term, you will save a lot of time and money on the field, and also a lot of health and safety risk for the workers.
Nice, thank you so much. Quick question about your hardware. Are you using a radar or laser altimeter to maintain the AGL, constant AGL? I know that Ben uses this terrain following. And what about you and Sniffer?
So for this, this is the BH12 from iRoman. So I cannot share this kind of information. I do not have the permission to share this kind of information. But most system will have most of the sensors on board, usually, depending on what you're trying to measure. For us, we also bring, I know there's question about wind speeds and everything. We also bring a meteorological station on site with us to have all this kind of information like humidity and wind speed.
Okay, thank you. Okay, what else we can discuss today? So many questions. Is there a way to create 3D profiles of the gas emissions with the sniffer?
Yes, I don't have examples on end, but you could measure a plume, gas spark out of a chimney on a different height, like 5 meters, 10 meters, and then you can model a gas plume. So this is something that's possible to do.
Thank you so much. Okay, Ben, there is a question for you. What about biogases and how to filter them out from measurements? Because
so for the BH12 from Iroman, we calibrate the gases on the field before. So we send a strict amount of air. The calibration takes about 30 minutes. So we really calibrate to make sure, because if you see on the H2S sensor, we go to pretty precise detection. We're at 0.5 ppm. So basically, we calibrate on site to make sure the sensors are reading the right kind of gases. So this is how we evade the false reading. And also, when we're using sniffer technologies like that, when we detect high concentration high concentration, depending on your definition of high, anyway, when we detect the gas concentration, we also go and send someone with a sniffer in N, like OTM51 in the United States, to kind of confirm, because the line of sight owners at first are not really trustworthy of the drone solution. I'm sure Ben maybe has this kind of issues with the laser, but so it's always good to confirm on site with another kind of unit.
Okay. Ben, what about TDLS and laser technology? How can you deal with biogas?
So this is a question that we've talked about in house, and the read across to other emissions. It's a relatively simple approach. The laser wavelength is 1650 nanometers, which is a wavelength at which it excites methane molecules. Therefore, it absorbs the laser energy, and we're measuring the delta between the laser energy that we're pushing down to the ground and the laser energy that is received back by the detector. So by tuning the spectroscopic sensor to methane, we look to discount other gases, and therefore spiral development. There could be other falcons that are tuned to different wavelengths in order to look for different gases. But no one solution is currently perfect, and within the spectroscopic sphere, you will get false positives if you if the albedo, if the reflectivity on the ground provides a reading at 1650 nanometers, you will potentially get a false positive. The false positive rates that we found are very low, and over time you begin to understand what the sensor is looking at, and you begin to understand the ones and zeros on the screen in front of you. You can discount false positives quite quickly. But this again is part of the journey, where only by using the sensor, and I think my colleague will back me up on this, is that only by using it, going out and flying it, do you begin to understand the benefits, but also the limitations of that particular collection technique. So at the moment, this sensor is tuned for methane. False positives can occur, but the hit rate is, from what we've seen, is very low. But we haven't seen plumes of other gases appear on our particular data sheet, simply because it is tuned for methane.
Yeah. Nice. Thank you very much for this great explanation. So it's time for us to wrap up. We still have 11 unanswered questions, and I promise that we will answer to all of you in direct emails. But before we wrap up, I would like to answer or to ask a couple of more questions to Guillaume and Ben. One is actually coming from Andrew Schroeder. I'll rephrase it. If you can choose between sniffer and laser, what would be your recommendations for maybe for different applications or for different tasks? How can we choose?
Well, I think like Ben said earlier, it always depends on what you're trying to do. So the kind of industry that you're in, the gases that you're trying to detect. For us, we use the sniffer because, like I mentioned earlier, I like the versatility of the BH12 and the other sensors. We like to measure many gases at the same time. So for certain industries, we can also measure particulates. So we just have, we like the flexibility that we can offer with the customers, but also in some situation we thought, oh, a laser could have been nice here because sometimes we cannot use the sniffer in certain situation. So it just depends on what you're trying to do. Both technologies are good. For us, we pick the sniffer. We like using the Pro instead of using the laser. So we're really going to detect the gas leak at the ground. But both methods are very valid depending on the industry that you are and the gases you're trying to detect.
Thank you. Ben, what is your opinion?
Yeah,
Let me guess. Let me guess. It depends on the project, and I'm totally agree. I totally agree.
So I haven't flown a sniffer, so it would be
okay.
it would be remiss of me to say that spectroscopic detection is the way. I would enjoy flying a sensor. You know, we could do a head-to-head. But for me, and this echoes the point that's previously been made, what is your statement of user requirement? Or what is it you're looking to try and achieve? And that will answer your question. For me, and you know, it's been a phenomenal presentation on the sniffer tech, and I've learned, hopefully, as much as everyone else on the call, and I've left with loads of questions about how the two could work side by side. But for me, when I was doing my literature review, and I had drone height, speed, reach, deployability at the top of the whiteboard, the Falcon did everything that I needed it to do in a reconnaissance role, because you know, there are other sensors out there that are designed for the surveillance role. There are other sensors that are out there that are designed to provide very, very accurate measurements and flow rate. And we're getting them with spectroscopic sensors. But for me, it was the initial on-site inspection in order to focus your attention to where the leaks are. And that's why I went down the spectroscopic route. But there is definitely a place for both sensors in any methane management strategy.
Okay, thank you. Thank you. Okay, then the last question. For newcomers and people who are just start considering using drones and sniffers or Falcon, what would be your advice? What is the best way to start, and what things you should do to maybe to avoid making mistakes?
Well, I would start by making sure you're using the methodology that your service provider is recommending. It's the same way if you're shooting LiDAR or photogrammetry. If you go off script, your results will not be accurate, and it will go poorly. Make sure you also follow your local laws on flight aviation, depending on your needs. It's not because you're using a more expensive technology that you will have better results if you're not applying the technique correctly. But at the end of the day, you will probably save a lot of time and money if you're using it correctly. So I would advise to start using it, and it's also a little more fun for the people who have acquired some technologies like that. So I go out there and enjoy it.
Thank you. Ben, and you, what would be your advice?
Yeah, 100% agree with the points already made. Yeah, before you strap a sports car to a drone, like flying should be completely natural to you. You shouldn't have to think about what your thumbs are doing. Automation is also your friend. I would I've been flying drones a long time, and I would argue anyone flying exactly the same flight profile in order to provide coherent change detection over time is going to struggle. So automation is really revolutionizing emissions inspection, where you can have the kit fly the same profile over and over again. So, embrace the technology and keep your play drone for the evenings if you want to get some manual flight time under your belt. But yeah, as previously mentioned, have a methodology and stick to it. It's not the most exciting flying in the world. You're watching an autopilot do exactly what it's supposed to do, because your role in this is analysis and data collection. So yeah, and rules and regulations are getting tighter. Opportunities are growing, but for example, in the UK, the CAA are they're starting to really have an inward look as to who is flying drones commercially, to make sure that everyone stays safe. But it's a phenomenal opportunity for anyone that wants to get involved, and I would recommend. It's going to change the shape of the future. So be a part of it. Absolutely.
Thank you, gentlemen. That was very insightful session for me, and I hope that was a very insightful session for our guests today. I had a lot of insights today. Thank you so much, and that was like a real luck to have you here today, and I hope to see you here again. Thank you for all the questions we had today. I promise we will answer all of them, and let's be in touch. Please subscribe to our YouTube channel to find other recordings and the recording of this webinar. And see you soon.
Thank you, Alexey. Thank you, everyone.
Thank you. Bye.